Well, hello to L, and we are going to shake it up a little bit today and talk about some angles, which is a fair bit different than what we have been talking about. We're going to be approximating some angles today, and you can see that in our goal. It says I can successfully estimate the value of an angle and use tools to accurately measure. So we're going to be doing both. We're going to be estimating and then measuring. So we're going to talk a little bit about what an angle is to start with. So an angle is a rotation. If you are standing up straight and tall and you take a jump and you rotate so now that you're standing backwards, people say that you've done a complete 180. Now you're backwards to where you were before. So here's how we represent 180. If you're facing this way with our line, and you can see it's got that little arrowhead on it, maybe I'll make it a little bit bigger so you can see it too. There's our big line. And here's our rotation point in the middle, right in the middle of the line. If we take that arrowhead and we rotate it around until we're facing the exact opposite direction, we've done a 180 turn. So we go all the way down. So we're going to rotate it all the way back. That's a 180 rotation. Now, since it's a 180 rotation to go all the way over, if we go halfway over, which is what this is, that's a half of 180. And half of 180 is a 90-degree rotation. And a 90-degree rotation has a special name. It's called a right angle. So we can rotate to right angles to each other. So these two lines here, this one that's got the green on it, and now this one up here, those two are called right angles to each other because it's 90 degrees in between them. Now any angle that's in between, so if I put this somewhere up here, that angle is going to be somewhere between 0 and 90 degrees. Now that looks almost like it splits it right in half. So I would say that this is probably half of 90, and half of 90 is 45. If we go a little bit further this way, it's going to be somewhere between 45 and 90, which looks like it might be about a 60 or 70 degree angle. So that's what I mean by estimating. So you have to know where these things are. So anything in this part where I'm rotating back and forth is going to be somewhere between 0 and 90 degrees, and anything between this part is going to be somewhere between 90 and 180 degrees. This is kind of fun. I could sit here and rotate this back and forth. Ooh, but I'm not gonna. We're gonna carry on. Okay, so we're gonna take a look at some definitions here. And there's three things that I want you to know, and that I want you to know what an acute angle is, what a right angle is, and an obtuse angle, and we've actually already talked about the right angle. A right angle is exactly 90 degrees. Now, an acute angle is a small angle. It's this tiny, it's a cute angle. It's this tiny little cute angle. It's somewhere between 0 and 90 degrees. And this one over here, this is a big one. It's an obtuse angle. It's big. So it goes somewhere between 90 degrees and 180 degrees. Now, at 180 degrees, we get just a straight line, and it would be called a straight angle. Go figure, huh? Mathematicians don't make up weird names. They go with things that make sense. So if it's a straight line, it's called a straight angle right at 180 degrees. So we want to estimate how big these things are, and then I'm going to show you how to use a protractor so we can figure out exactly how big these things are. So now, first of all, this is a little witty bitty tiny angle, so it's an acute angle. Okay, this is the angle we're looking at, this rotation in here, and we want to know about what it is. So it looks, now remember, if I put this up here, that would be a 90. Does it look like it's splitting it exactly in half? Actually, it looks pretty close. I'm going to say that it's a 45-degree angle. About. Might be 46, might be 42, might be 47, but I'm going to estimate. An estimate is your best guess. I'm going to estimate that at 45 degrees. Now this one here is kind of rough because they've switched it around on us. You could rotate it. You could pick up your paper and rotate it till it looks good for you, and you can see that it's not quite 90. It's close, but it's not quite. That is not straight up and down. So I'm going to say it's a little bit less than 90, so maybe 80. It might be 85, but we'll just estimate at 80. And this one over here, again, if you have a piece of paper like this and you've got it written kind of funky like that, there's no harm in turning your paper around. Now, I don't want you to turn the computer around or the iPad or whatever you're viewing this on. So we can just spin it here. Okay, but there's no harm in turning your paper around to get your bearings. Now this is definitely an obtuse angle. It's bigger than 90, but how much bigger than 90? Well, I'm going to put on a couple of reference lines here, just rough reference lines. I'm going to finish the 180, approximately there, and I'm going to put the 90 up there. Now is that halfway over that way? No, it's just a little bit more than 90. Well, a little bit more than a little bit, but still, it's not a lot. So I'm going to say it might be 20 degrees more than 90. Maybe it's about 110. Now, I wonder if we're right. Well, this would be 110 is the whole thing. Now I'm going to erase that so that we can say that 110 is the whole thing. This is 110. Okay, now we're going to figure out how we can actually measure these things. Now, I'm sure you've used a protractor before. And I've got some information here. It says put the center of the protractor on the vertex of the angle. What's a vertex of the angle? Well, that's just the point of the angle. Okay, so this is the vertex of the angle right down there. And it says with the zero line on one arm of the angle. Now, what do I mean about an arm of the angle and what do I mean about the zero line? Well, take a look. There's a zero on the protractor there and a zero on the protractor there. So that means that this line between those two zeros is the zero line. And we want to put that on one of the arms of the angle. Now, an angle has two arms. It has this arm and it has that arm. So we're going to take the protractor. Whoops, that turns it. I'm going to move, whoop, that makes it bigger. Let's make it smaller. I got to move it over. There we go. Now we're going to put it on one of the arms. Now I got to put that center piece on the dot and I got to move that on one of the arms, which I just did. So that looks good. Now, how do I know I've got it on the right arm? Well, if you had put it on this arm, we couldn't measure the angle because the angle is not inside the protractor. You got to make sure that this angle, I'm going to color it in yellow, this angle that's in here, it has to be inside the protractor or we can't measure it. So if you accidentally put it on the wrong arm and it's not in there, you may have to switch it around a little bit. Okay? So we're going to rotate that back down to the, let's put it back on there. Oh, come on. There we go. Rotate that back down. Now, we'll take a look at where it comes on here. So I'm just going to grab my pen and point on here. And that's the line we're looking at. Now, how do I know which line to read? There's two sets of numbers here. There's a 50 here, and it looks like we've gone 1, 2, 3 spaces past the 50. But there's also a 130. So this angle is either 53 or 133. Now, how do we know which one to use? There's a couple of different things that you can think about here. And the first thing is that we know, and I'm going to move the protractor now. Oh, maybe actually, oh, wait a minute. We know this is an acute angle. It didn't quite get to the 90 degrees. We know that it's small. It doesn't have that square corner in it. So since it didn't get to the 90 degrees, we can safely eliminate the 133. And this is a 53-degree angle. Now, it's not even 133. It's actually, because we have to, if we were reading that thing, it's going the other direction. We always start at the 0. So if I want to read the big numbers, I have to start over here and read this way. If I want to read these smaller numbers, I have to start here and read this way. And since this angle, since the line that we went through goes through this 0, it's these numbers we want to read. Okay, so if I'm going this direction, it's 53. Okay, so now we're going to go and measure the angles that we estimated before and see how good we got. So I'm going to take the protractor and we're going to go down to this dot there, and we are going to see how well we did. Now, this is hard because this is a smaller angle. Now I can cheat a little bit. You can't do this. You'll have to sort of guesstimate on yours. You'll have to go out and say, okay, I know I have to start at this 0, so I'm reading these numbers. And it looks like it's gone about maybe 3 places or 4 places past the 40 line. So it looks like it might be 43. Now I can cheat a little bit on that. I wrote 45. Crazy. I meant 43. Okay. With my little handy dandy protractor, I can actually pull it up until it's on the angle and we can see what it is, and it looks like it's 43. Okay. Now let's measure the next one. Oops, gotta move it. So we're going to put this on the dot and we're going to rotate this. Now do I rotate it? Oops. Do I rotate it this way? No, I know I can't put that. I'm not going on this arm of the angle because the angle's not inside the protractor. So I got to pull it back down this way. There we go. Oh, that looks dead on 80. Right? Because this is the line we're looking at here. That's dead on 80. That's it. I always like when those ones come up. 80 degrees. And then this last one, how are we going to put it on here? Again, you can move your page if you want to. Okay, I know it's not going to be there. I can go over to here, or I could go over to here. It doesn't really matter. Okay, if I line up this side, I'm starting at this 0 and I'm reading the top numbers. If I line up this side, I'm starting at this 0 and I'm reading the bottom numbers, and I think that's the one we're going to have to do because the protractor goes off the screen and I couldn't see where it stopped, so I'm going to have to go over here. And this looks like we've got to start at this 0 and read these numbers. We're going all the way around to where this is. That looks like it's probably about 124, I'm going to guess, at 124. Now, how close were we? We've got 43. Rid of the protractor. I'm going to make it really small, move it away. Okay, we've got 43, 80, and 124. What did we estimate? Let's go back. It says 45, 80, 110. So we're a little off on the 110 estimate. Okay, and that's how you use a protractor. So you have a worksheet to do. This one went a little long. Sorry about that.